I want to make an integration between two systems at my company. And I was like, it's going to cost $30,000 to do, but I only get $20,000 worth of value out of this over the first 2 years. Can't make it happen. Now I can build it for $10,000. So now it's economically useful to build this feature.
I still maintain that it's all fake. It's not actually reasoning. It's the appearance of reasoning. It looks like reasoning. It's fantastically efficient and effective search.
So what the reasoning models do is they talk to themselves in a way for a little bit before they give you back the answer. And you still now have the error accumulation problem. But what turns out to be, if you train these models well, it actually starts self-correcting its own thinking.
I'm Michael Small. I'm the director of UWA Data Institute and also a professor of mathematics at UWA.
AI has been around for quite a while now, but for the general populace, it's kind of just come into existence in the last couple of years. What surprised you most about that sudden popularity?
That it works. So I've been an academic researcher for a while and published a lot of papers that lean on concepts related to AI. Part of my PhD was on a machine learning algorithm to predict time series data. So predicting the stock market, all that sort of stuff. And it doesn't work. I got a nice research position with the bank out of it, but it doesn't work. But what surprised me most about the last couple of years is the extent to which specifically generative AI models actually produce things that look reasonable. The idea is really, really basic, and it's an oversimplification, but essentially, yeah, it's a random process picking next words from previous words. That's a bit of a trite way of saying it. People say that all the time, but at one level, that's all it is. And I don't know, Jerome's going to tell me there's lots of things to add on to that, but that's the underlying idea. And that's an idea that people have been playing with for a long time, and it doesn't work because you need so much data to make it work. But the incredible thing for me is that we've got to the point where actually it seems like because we've got so much data, there's actually been a kind of tipping point, and it's actually producing things that are at least have the appearance of coherence. So you can see I'm being cautious of that. Exactly like
Yes, subbing cautious immediately. We'll give you more wine. Viren, different question for you. How is AI impacting your field currently, and what do you think it'll do in the future?
So I typically have two hats in my career. One is developing skills in people, so training and education. And my other hat is computer science. I'm a software developer by training. They're affected quite differently. Any software engineers or software related people here? I know you have a few. And so our field is transforming in front of our eyes quicker than anything I've seen in the last 20 years. And I speak to a lot of software engineers that say that they are at least 50 to double as productive at the same quality. And that is very rare that happens in any industry, right? So it's massively transformational. What is really not surprising, what I'm super curious about is what does that do to jobs, right? And so for a little while, it looked like software engineers were less in demand. So job ads, for example, for software engineers, almost in every Western world over the last, between 2023 halfway and 2024 halfway, 2025, was starting to drop, which is scary for people in our field. But the last year or so, at least the last 9 months, the reverse is happening. So software engineers are in more demand than ever. And so how can it be like, let's say they're twice as fast. So, you need half of them is the short-term thinking. But the second part of that is that a whole bunch of tasks that you previously would not use software engineers for because it was too expensive are now economically viable. So let me give an example. I want to make an integration between two systems at my company. And I was like, oh, it's going to cost $30,000 to do, but I only get $20,000 worth of value out of this over the first 2 years. Can't make it happen. Now I can build it for $10,000. So now it's economically useful to build this feature. And so, yes, we need less software engineers for the workload we had before, but we added this whole new bunch of workload. So this is shifting really quickly, and I don't know where it will end. Do we need twice as many software engineers or half? And I don't dare to do a bet. I just think it's like, holy shit, something is happening here. So that's probably the biggest thing I see.
All right. When AI gives us a beautiful and sometimes useful answer, what is actually happening? Are we looking at something that genuinely resembles reasoning, or are we just looking at statistical pattern matching?
So this is essentially why I'm here. Because this is where Jerome and I disagree, I think, most markedly. I still maintain that it's all fake. It's not actually reasoning. It's the appearance of reasoning. It looks like reasoning. It's fantastically efficient and effective search. So the examples from software engineering, and I've used it myself to write code for my work, either as research or in teaching, and it's very effective and very efficient to do that for small tasks, which I can then piece together. But I see that essentially as it's a search task. It's a pattern recognition task. It's not. Maybe I'm just being romantic and trying to differentiate some sort of human reasoning from everything else. But I still, because I can see how the process comes about, I don't feel it's the same process as human reasoning. And you can extend that to just last week. AI models have proved mathematical theorems that human mathematicians have failed to prove. And not trivial theorems, theorems that they'd tried to prove and failed to prove. And so is it reasoning? It's stringing together logical statements using facts from the corpus of the literature to construct something which humans can interpret as a logical argument. That's about as close to reasoning as you can get, right? But I still maintain it's not actually doing the reasoning.
So my understanding of that mathematics was that it used area from a different area of mathematics to solve it. So how is that different?
So this is not something that's unusual in mathematics. Very often, the best mathematicians will pick up techniques from one area and transplant to another area. A lot of mathematics in different fields, it is actually completely transferable. So you can talk about points in a vector space, or you can talk about combinations of polynomials, and actually the same language, the same mechanics can reason on those two sets of things. And so very often human mathematicians will try to prove things by going in a different area and taking techniques from a different area and using it in their own area. And this is what the AI did as well. What it did that the humans didn't do is it went in what was an unexpected area for the humans. The humans that had tried to solve this problem all approached it in one particular way and got stuck. The AI went in a different way and found fruitful results that it could use to prove it in a different way. So yeah, it is using stuff from a different area, and that's why I say it's about search rather than reasoning per se. But this is also a technique that the very best human mathematicians, the Fields medalists, Terence Tao, who's the Australian Fields medalist, uses exactly the same technique in his work. So to argue that one is reasoning and valuable and the other is just search is a little bit reductive, but I still think there's a difference between the process.
I know you're supposed to ask a question. I do have a question, and
Yeah.
and I'm very far.
Can I veto his questions?
Yeah. You can. But I think you study complexity
Yeah.
as well, and my understanding, what part of complexity is emergence, right? And so is it strictly, in your view, not even possible that we have reasoning as an emergent property from these complex systems, or is it just unlikely? Like, where are you on the strictly not possible versus I don't think it's the case?
That's a brilliant question. And that's that's exactly the argument that I was making earlier in terms of like ChatGPT suddenly getting to a level where you could have a conversation with it. It didn't feel completely fake. We put enough data in that suddenly it behaves differently. That's what emergence means. I think that I still argue against the property that current AI can generate emergence reasoning on the basis that it's still a finite state decimal digital machine, and the human brain is not. And I point to that difference as the core reason that we had some emergent properties that machines cannot have at this level. Build a quantum computer, then all bets are off.
Yeah. So I see things mostly the same, but a few things that make me so a model from 5 years ago would behave the way that Michael suggests. One of the things that seems to happen if you have a lot of data and you forced kind of all the data into fit in a model and it doesn't, so you have to compress. When you compress data, you can do that in various ways, and it seems that what these models do is try to simplify the world a little bit, so it's more efficient to store. So let's say you store the location of 1,000 places. You can try to describe them relative to each other, which is really not efficient. But if you would invent a coordinate system like north, east, south, west, you can kind of store the relative positions. You don't have to store the relative position. You store the XY positions, and then you can later on infer the relative positions. Does this make sort of sense to everyone? And so if you then inspect these models, one question is, do they form some picture of the world where they figure out that north and south and east and west exist in its brain? And my understanding is that certainly they make these type of abstractions, and they can use these abstractions to draw conclusions. You drop in a new place it never heard about, you tell it where it's relatively to one place, and then it can infer how it's relative to another place. And it can do that because it has a basic world model. To me, this is a form of reasoning, maybe a primitive form of reasoning, but if you have a world model, and the world model has a lot of elements in it, like north-south is just one aspect of a world model, you can come up with novel conclusions, novel insights, and interesting thoughts.
So the navigation system on a Boeing 747, is that a world model?
It doesn't. So second bit. So this was already happening in for example, the ChatGPT 3.5, which showed strong evidence that it didn't reason at all, or at least only one sort of shape of reasoning. Then we got reasoning models, and the name are a little bit suggestive, and so let's remove that label for now, and bear with me for this intuition, right? What is 2 times 16? 32. Everyone knows that within about a second, right? You don't have to kind of reason through that. How many doublings does a startup need to do to go from one customer to everyone in on Earth being a customer? So also 32. So the answer is the same, right? The question is not super much different in length, but the steps you would have to take to come up to the answer. To do one, you can do kind of in one shot, And the other one, you have to go through a few steps. You would have to do the log of the thing. And there's probably 2 people here in the room that can do it in their heads. Maybe Michael and maybe one other person. Not me. I had to ChatGPT answer. So this is interesting, right? So same question length, same answer, but the process to get there in one state required steps, and in the other one was an immediate answer. So the AI model still 3 years ago only did immediate answers. Boom, answer, and that was it. And Jan LeCun, one famous Facebook researcher or French researcher, said the problem with this is it gives an answer and it gets it maybe 99% right. And then another answer, 99% right, 99% right. But if you then do that 1,000 tokens long, the errors accumulate and they can never kind of do proper reasoning until reasoning models. So what the reasoning models do is they talk to themselves in a way for a little bit before they give you back the answer. And you still now have the error accumulation problem. But what turns out to be, if you train these models well, it actually starts self-correcting its own thinking. So it does a few steps and it's like, hey, wait a second, that actually didn't make sense what I said. And so what they thought was a fatal problem in error accumulation turned out to be wrong. So my belief is that these new reasoning models do at least some primitive form of using their world model to draw reasonable conclusions and inferences. Interpolation, yes. Extrapolation, yes. Invention, no. So 2 types of reasoning, not the fun type of reasoning. So that's my very long.
Back to Boeing. Thank you. So back to Boeing, because actually, if you think about the trajectory system in an aeroplane, it's performing exactly the same sort of prediction. There's a small error in each step. And if you add those errors together, then your flight that leaves Perth is not going to end up at Sydney. It's going to end up somewhere in the South Atlantic, somewhere in Antarctica. And that's because those errors accumulate. But the system does exactly the same sort of self-correction that your reasoning models do, in that they periodically look at the trajectory overall and then correct the whole thing. So on the level, and I realize that we're talking at a level of abstraction here, but on that level of abstraction, that it's doing exactly the same thing.
Agreed. So I've got one more question for you. So 4 years ago, the best AI model could not do end of primary school mathematics. It was, if you had a question, there is a tree with 4 apples in it, and then you duplicate that tree and pick out 1 apple. How many apples are there in your hand? The answer is 1 because you picked 1, or something like that. It would get that right like 5% or 10% of the time. Then a year later, it figured out how to do kind of early high school, then late high school a year later, and then about 2 years ago, it started to win Math Olympiad for high schools. Then about a year ago, it started to do PhD level-ish in some subfields, and you can correct me because you're the mathematician, not me. And now we're seeing early senior research level insights where they can draw some conclusions and do not substantial but interesting mathematic work. And so is there a threshold, is my question to you, where you would be like, dang, it must be doing some sort of reasoning, because it's clearly now better than 99% of people in mathematics. That's not reasoning yet. So what would be evidence for you that this reasons?
So first of all, I'm not going to not answer the question. It definitely is performing mathematics at a level that could be published, and in fact has been published in mathematics journals as new research. It is getting new mathematical results. And it's not far away from being able to be set loose on some fields of mathematics to do stuff that professional mathematicians are doing now and do it much better than them. In some fields, mathematics is very, very particular here, and it's different from a lot of other disciplines in a couple of ways. One, there's a big leap between, as you described, like doing primary school mathematics, doing counting the number of R's in strawberry. The last example I saw, it actually then misspelt the word and took out an E, but that's beside the point. Counting the number of R's in a word, the number of apples on a tree, doing basic arithmetic. If you get a language model to do basic arithmetic, it's not at all doing basic arithmetic in the way that we think about doing basic arithmetic. It's using processes of orders of magnitude more complicated than it needs to solve that simple problem. Through to the sort of research level mathematics that you're talking about, where essentially the skills that you need to do this is search, pattern matching, and exhaustive reasoning. And these are things that ChatGPT or large language models can do very well. So that's where it excels, and that's why they choose these specific types of areas. I should say that even the examples from just last week, the paper's been published with the large language model's results, and they've said this is the prompt we gave it. They don't say how many times they gave that prompt or what other prompts they gave before that, but this is the prompt we gave it. This is the response we got. And now here is a 10-page paper deciphering that response so that we can talk about it in a way that makes sense. So that to me speaks to the gap in the reasoning. It's filled in the steps, it's done the search, it's connected the logical operations, but it's not presenting a chain of reasoning in a way that makes sense immediately. If I could come back here in a year's time and say the same thing and be pushed a little bit further towards the cliff where AI starts to reason. And it still comes down to, is it doing something which is not just a simulation of activity versus is it doing something genuinely creative? I can paint, I think, like Jackson Pollock. I can take you don't know Jackson Pollock is an abstract artist. His paintings look like blotches of paint on a canvas, sell for lots of money. I can throw paint on a canvas. Mine don't sell for quite so much, but I can do that simulation. Just as a PhD student, and I know an example of one PhD student from the University over East whose thesis I'm examining at the moment, a PhD student can ask ChatGPT to write the introduction for him, and it'll do something. But it's only a simulation. And when you look at the details are still not quite there in terms of the way a human would do it. And I say reasoning, in some ways, my definition of reasoning is thinking in the way that a human would do it.
Ask Michael one more question.
One more question.
It's a double barrel question. So two questions. One, and they're related. Do you think humans reason more often, regularly? Probably. And then the following. What percentage of our jobs require reasoning? Because I'd like to make it kind of bring it a little bit back to the practicality, and so I will stop there.
So a lot of my pushback against reasoning, and we had this discussion where consciousness was substituted for reasoning before. My pushback on this is a philosophical one more than anything else, and I would certainly argue that there are plenty of prominent examples of human beings exhibiting very poor reasoning, not reasoning at all, or behaving in a completely random manner. So I don't think that either reasoning, I'm not claiming that reasoning is an exclusively human activity, nor that it's an activity that every human chooses to exercise, at least not all the time. The economic part, the jobs part of it, the question. There's a lot of stuff that a lot of us do every day that is not reasoning in our work. I spend a lot of time answering emails, maybe from Julianne, and a lot of that doesn't require reasoning. It just requires me saying, yes, approved, full stop, send.
Right.
So there's there's a lot of activity that doesn't require reasoning and that can be taken over by AI. And I'm actually optimistic about this in the way that you described with programmers. It is going to increase productivity, but you know what that means? That doesn't mean we need fewer programmers. That means we can do more stuff. And we can do stuff that we otherwise wouldn't have done.
I love your answers. Thank you.
If you had a human who, say, is a doctor or a lawyer, and they are making a gut calls, they don't necessarily have the results in front of them, but they can see something's wrong or they can smell something's wrong, and they're gonna go, I think something, and they kind of make this gut call. That's usually kind of accepted that it's based on pattern recognition. Was the argument also that humans are just pattern recognition machines?
A lot of what we do is pattern recognition, yes. And a lot of the examples those sort of examples, they occur all the time. I spend a lot of time working with CSIRO and the Mineral Resources Unit. Anyone here a geologist? Mining? Yeah. So a lot of what, and the geologist might throw things at me here, but a lot of what these guys do is they look at scans of rocks and identify the valuable bits and the not valuable bits, and then make up a story about how they're connected. Okay? And turns out that if you give that same task to a bunch of different geologists, they mostly agree, but not entirely, not all the time. And so one of the things that we developed for them was algorithms that would tell them what the machine thinks. And providing the geologists with what the machine thinks actually made the geologists agree with each other more. Again, George, you can contradict me or argue against that point, but what the machine does is it's pattern recognition, but it's pattern recognition in what is essentially perhaps a more explainable and consistent way. None of this is, on the machine part, is reasoning. It's purely algorithmic. This is not AI. This is not generative AI. This is not. There are algorithms now that do all this stuff as well that are Gen AI. It's not none of that things. It's purely deterministic algorithms that I can write down. I can describe to you exactly what it's doing, line by line. There's no reasoning at all. What the geologists are doing, yes, they're reasoning. But the AI just gives them an explanation which helps guide them.
To give another example, it agrees with what Michael said. Nature, one of the kind of most famous science publications, had a paper last week where they did automatic academic research reviews. So it was a peer reviewer done by AI. And so they had AI review papers, and then they had human scientists review the same papers. And then they had human scientists look at the reviews and judge, are they better? Which ones are better? And they didn't tell it was AI or humans, they just let them rate it. And so two cool findings. The AI papers, the AI reviews were rated higher, slightly higher, than the average to 75th percentile of the human reviewer. So better than your average reviewer. And this is in Nature, right? This is a very prestigious journal. But, and if you look at AI and humans, do they give the same type of feedback? No, they're slightly different. But what's really interesting is that there is more variations between humans than between AIs. So what that means is that if you have 3 human researchers, one might pick up point A, and the second might pick up point B, and the third one point C. Where if you do 3 AI things, they would pick point A, and point A. So what the conclusion is, it is super useful to add AI to the process because it will give high quality, better than most of the humans, insights, but it can't cover the breadth yet of a team of human reviewers. And I think that speaks a little bit to the same point that Michael was making. I think it's so useful, but not replacing. And
yeah, no, and on the review example, I have a similar example for you as well. So one of the journals for which I'm the editor-in-chief, and I get a lot of papers coming in and my job is to quickly read the papers, decide whether or not it's in scope for the journal, whether or not it's rubbish, whether to send it to a human reviewer to actually waste spend their time doing that or whether to just send it back to the authors. And this tends to be how I spend my Saturday afternoons. And one Saturday afternoon, not so long ago, I got a couple of papers in, and second paper, I'm reading the abstract, so the summary of the paper, I'm reading it. Hang on, I just read exactly this 2 papers ago. 2 completely different papers, 2 completely different sets of authors, 2 different countries, 2 different topics. The first 3 sentences of the abstract was, except for 2 words, identical.
Yep.
AI picked A both times.
Yep.
And in review, that's it's both useful but also limiting. It's useful in that it can give you the thorough things that you need to get right. But part of the point of review is you want to get different opinions, different perspectives. And especially with a journal like Nature, what they're looking for is, does this paper make sense to the geologists, but also to the mathematicians?
Well-
Alright, this is the fun bit that I make the little note. I put a shirt open to the cab. I think a backup tattoo didn't know the answers, but here we go.
I would like to add one thing. Just
Take your questions. How many questions have you had?
it is just a mental model that I think is very useful for everyone here to think about AI. So I put AI in 3 classes, or topics in 3 classes. 1, a human does a task, and adding AI makes things worse because it confuses the human, it distracts them, it's so poor, it's time consuming, it just makes things worse. So human plus AI, don't do it. The human is better. And there's plenty of tasks. The vast majority of tasks are in this camp. Second task is a human does it. Adding AI makes the task go better. Software engineering seems to be now well truly into that era. Add AI to it, and the software engineer produces more good quality code than without.
Depending on the software engineer.
Depending on the software engineer. But for medical doctors, for example, radiology, it seems that adding this is useful for scientific review. Adding an AI can be adding the overall quality of what gets done. That's category 2. And it's really important that you know in which category you are, because people confuse them all the time and like, oh, let's just chuck AI in. And if you're in situation 1, you don't want to chuck AI into it because it just makes things worse. But if you're in situation 2, you want to mindfully, not blindly, but mindfully add more AI. Then there's situation 3, where the human is in the way. Adding humans into the process makes things worse. And
Two pointing at you.
I wasn't. Moderator. Yeah, we see it. Yeah. And 2 examples there is, for example, chess. So one thing that if I understood this article correctly is they had an AI playing chess, good AI playing chess, and they had a team of humans with AI, and the humans had plenty of time. These were all grandmasters, so they had time to discuss it, and they tried to interpret the moves of the AI that was also helping them, and sometimes they steered it a bit away from what the AI proposed to do. And every time the human did that, they started losing, because the AI could just think so many steps further and so many more nuances that humans couldn't pick up, that adding humans, even the best grandmasters, in a group was actively harming the chess of the AI. Another example is, it seems that with weather forecasting, it's another thing. Like if you add human intuition into that process, they just kind of make it worse. Just let the machine figure it out. And so it's really important, I think, as a mental model, like instead of like AI is good or bad, or is AI useful or not, the question is like, which of the 3 buckets am I in, or is this task in, and then add AI or not.
Yeah, I've got a question. Well, I guess for Marple, but in a majority, they'll address some, will say the value of the geologist is to come up with the expat or we do the interpretation, because they will never find new oil or never find new mining because it's based on statistics and analysis. He patented the Grand Core. To find the next biggest thing, we had to come up with some really bright, wild idea. And the benefit of doing that is that sometimes you pay that because you could have recused. So you might have a chance to pay that, takes for all of those other mistakes that you've made. So that's why it's still into jollity. But the question actually is that the Michael, and we hear that most AI models these days, that the five largest, the article that I was reading here was called about, is that four often resist being upgraded. That they actively resist being shut down and updated to another system. So that's not something that can be learned from the data that is fed to these things. So isn't that some sort of intuitive reasoning thing, survival mechanism that we need to know about? Or is that story just a whole lot of football?
Sorry, I'll catch that with a grain of salt. That was not possible.
I mean, that's the
Oh, I'm a computer electrical engineer. Well, I've got my utility stations of this, and I study biomedical engineering part-time at UWA. That is feasibly not possible to.
But Renki said not on we're saying
An AI, okay? It's a sort about totally really few professor. They are not reasoning. They're just pattern matching.
So we're saying that the software can't resist being shut down. Okay, excellent. Michael?
So I'll agree largely with what you're saying, but I want to go back to the geologist point first, because I think you're making a very good point here about what these machine learning models can and can't predict. When you're talking about the X factor that you can find, you're talking about an outlier, a new event, a novel. No, and he saw nobody hit a border. A novel view of things. But it's awesome. Yeah, and that's where these models are weakest. And what's we often confuse with that is, and the example in the mathematics is a new combination of existing things, which is what AI has done in other fields. But I completely take your point about the X factor for geology. To the point about AI's resisting shutting down, this is not something that I've studied extensively, and I know you have an opinion and you can expand on this more than me. But from what I've seen, when these stories come out, they are largely in some sort of setup constrained situation. It's the systems don't exist in full autonomy to go and make their own future. It's not Skynet. It's not going to
Capital, right? It virtually impossible. Yeah, it's just for learning. I'll give you a good. I'll try in terms of mathematics. As an engineer, doing that professor that we also do a lot of expert math, right? The maths to tell the AI to respond to you no matter what. It has to respond, right? As a software engineer, they rewrite software. Really need bit, this to bit, else to the bit. If it doesn't match, give us an result of a 0 or something. That imagine that the large language model, a Gen R, was to actually say to you every second call of that mod.
So there's three threads here. The first thread was on reasoning, and I don't want to kind of repeat things, but I like to think in trends. And one thing we've seen over the last at least 10 years, but probably more like 20, is that models have become more general and more sophisticated in their apparent reasoning. Let's keep it with apparent reasoning. But the more general is super important, because 4 or 5 years ago, 5-6 years ago, when people were talking about, we would love models to be general, they were meaning things like, it can translate not 2 languages, but 4. The breadth of the tasks that one model can do today was absolutely unimaginable 5-6 years ago. And what we have today is well beyond what they then considered very general. And so my question is, and I can't predict the future, but if I see a long-term trend of something being more general in its ability and more sophisticated, then having a firm opinion it can't do the next step because it can't do it yet. Well, we have seen about 20 times, it can't do this. It will never be able to do this. Oh shit, it can do it. And that repeated and repeated and repeated and repeated. I'm repeating myself to myself and repeated and repeated. Then being firm to say AI will never do X, while it is on that same type of trend, I would just be careful with having that opinion super firmly. I'm not saying it will. I'm just saying, like, given the history, I would keep an open mind.
But that's not generalization or reasons for abstraction at all. If I take away a large language model's ability, so they use a process called a chain of thought, which is a data set you can download and you can train. I could get one of those open wave models that I can train the exact in some thing. If I take away, let's just say language is an example. If I take away the ability for it to translate on English to Italian, and then I gave it an example from a dictionary, English to Italian, you can do it.
So this is called zero shot learning.
Exactly.
And-
pull up to it.
I couldn't 5 years ago, but I think you're wrong, sir. And I don't want to go back and forth, but that is not my read of the science.
And then I think that we're gonna hear from Holger and if there's a not.
Quite a bit of a different tangent. So I think to control the discussion, I think we move in large hybrid models. So I guess, but probably, at least in my head, I was just imagining that chat dialogue or chat modality. But we're seeing robots, like physical man at the stake, where, basically embodied machines that these AI models were increasingly put into. So I'm just wondering, what do you add a body to, or give a large language model a body? Does it change this discussion in any meaningful way, or what does that change this word body?
It adds to the discussion. It adds to the discussion. It adds to the discussion not just because there's a physical manifestation of the software, but because the software now presumably has different data coming in, different modes of information coming into it that you didn't have previously. I still maintain that the issue is, for me, is intent. The idea that the algorithm has an intent to do something is still not there. And that's where I will stop and where you're going to push forward.
And I still have a thought on the robots, the AI trying to keep itself alive and escaping, which was asked previously. Maybe just to explain how AI takes in data and then puts out other data, and most of the time it's text, right? You put a bit of text in, and what happens under the surface, it gets converted into tokens. Everyone has heard about tokens by now. So there's kind of numbers, and those are transformed into some kind of type of mouth, and then spits out tokens again. So adding, first what was added was images. And actually the images that get converted also into tokens. So from the perspective of the language models, it's just tokens coming in and it spits out tokens on the other end. When we add robotics data, in comes vision in the form of tokens, typically the actuator position, like where are the limbs at and how are the motors and maybe sensors.
Or how your car steers.
Or how my car steers, as, again, tokens, if it is a large language model based system, and it spits out tokens. Some of those tokens might represent move an arm or push an actuator. So just to detangle, like, how does that work? Tokens in, tokens out. What it does seem to do is, I still, and we disagree a little bit on that, is that this system seems to form world models. So they think about how things relate to each other, and adding the modality of a body, where you have intuitions on gravity and how things move, and adds again to the type of reasoning and interactions and causality that it has seen in its data set. and can use to predict the next token. But in this case, that is how a ball moves, or how a person will interact, or how someone will answer, which in my book is a form of reasoning. But
But I think to answer like all three questions in one way or another, all of these models are operating on a reward. Right? The large language model, the ChatGPT, be it Yoram's Tesla, be it your Cyborg, there's some reward function that it's trying to optimize. I think the proof example, the objective function was to get the proof right, and that was trying to optimize that reward. And those rewards, the choice of those rewards are what stops the robots from taking over, because the robot doesn't, its reward isn't sentience, it isn't the ability to love and to go and make little baby robots, or whatever it wants to do, or take over the world. It's simply to get him home in one piece, without running over any pedestrians or cyclists. And so the examples the question that started this, the examples of these large language models refusing to be shut down was because the reward was tinkered with in such a way that you want to survive, do what you can to survive. I think they are engineered for a useful headline.
It's an illusion. It's a hype, right? It's just hype. Recently, right? Anthropicus talk about, I don't know if people have heard of Crawl before, right? So it's their latest model. The Anthropicus made the argument that in a sandbox environment, Lupus has escaped the sandbox environment, jumped on the internet, started posting, bragging on how it actually escaped, and then sent the engineer an email how it actually escaped. Now, if anyone works in network engineering, they will tell you that is virtually impossible. A sandbox.
Very love it. Is it a notebook question and then Dan with us? And then Mo and then Dan.
All right. That's a great discussion. I've got a question just about reasoning. We get back to that. Does the threshold of reasoning, does that include an understanding of what you're reasoning about? And what I mean by that is when we say the sky is blue, we understand what the color blue is. Whereas when a large language model says that, it's just pattern matching the word. It converts that word sky and blue into numbers, knows they're probabilistically close enough to be presented back to us as humans, but doesn't know what the sky is. It doesn't know what blue is. It just knows that those are connected with a stronghold. So what's your thoughts on that in terms of that threshold for reasoning?
So I'm not a philosopher, but my answer would be yes. I think undeniably reasoning, you need to know what you're reasoning about. Otherwise, you're just manipulating tokens or chess pieces or whatever. You're performing an optimization. It's knowing what you're referencing that matters. And now you're only going to talk about world models.
I can, but on the AI escaping, one little sub-experiment that was being done is if you add more examples from dystopian AI books or robots escaping or texts around that stuff in its ends of training phase, do you get more escape-like behaviors? Versus if you talk more about AI being good and protective of humanity, and you see a massive change, like factor 3 or so, in the escape attempts. So it is not inconceivable that all the dystopian books we've written about AI are actually kind of telling it a bit how to behave in those settings. And one of the things that's really apparent is that it actually, and they can investigate this, it knows that it's being tested because it kind of picks up that it's an artificial environment that it's in. And so it kind of does what we expect it to do. So you're measuring kind of what you want to measure. So I would take it with a yes. Can you trick a model into convincing you that it wants to escape? Sure, you can. is it innate that these systems have some pure innate drive that we can't get out of it, that they always will try to escape and take over? I don't think so. That's
And on that, the real recipe, the not unconditional growth. And the last coaching whole book what I went back.
But I could be talking that look at me and I pick people better. Language and
Policies will. And I want to reaching the limit of the science. And discover. Um, a word like raising on routines or some novel had made several up to the thing. And now it's directional for paper for copper, but they never had even it. How she asked AI a couple minutes ago, can you raise it? And it opened what is the
But was it lying to you? Was it trying to get out of your phone and escape?
Would encourage you to really prefer perseverance and AI easy. He makes it very, very active.
How does it make it was hey,
Not up this other than the equipment, but I don't the equipment was from confidence right there. Bo from other than it. If you click get it, you give it really this and no what listening.
So who here will you use?
Moneyman people look. Right now, the Moneyman chicken it wouldn't for a minute. And I could get it on the Moneyman. Oops.
I don't know.
Yeah. So
This is not a question you might give one yet.
no, I think it's perfectly valid, and in some ways, yes, well, for a start, we've had a number of times in the last few years we've redefined what the threshold is for AI to be an intelligence, right? The Turing test no longer means very much. I mean, certainly I can't tell the difference between what AI produces and what US politicians produce. So there's that doesn't mean anything anymore. And we do keep moving the goalposts. And I'm guilty of it, and I've had this conversation several times where I've pushed the goalposts further back, and I'm pushing it back into philosophical territory unashamedly, in that I think there's something fundamentally different about reasoning the way that we do it and simulation, which is what I believe the machines are doing. But to your broader point about language around use of AI in general, who here, when you use ChatGPT, says hello to it, or says thank you, or please, or calls it him or her, right? All of that's completely unnecessary. That's up anthropomorphizing something which is just a tool. And and it's useful for the companies selling this stuff to extend on that anthropomorphization and talk about reasoning, talk about thinking, talk about consciousness. I mean, but they're constantly pushing those words that used to mean one thing to mean something slightly different. Maybe I'm particularly attuned to it because mathematicians are very good at just hijacking words to mean other things. We take common words and just use them to mean something that's completely different. But computer scientists and AI researchers do it all the time as well. And the connection is sometimes quite tenuous. Whether the Chinese would be different, I'm not sure that it would. I think it's an inherently human issue that we want to see human properties of these things. But again, I'm not a philosopher.
The Chinese question actually has a proper answer in how the models work. And so what's kind of cool is if you have an AI model, there's kind of neurons. They call them neurons. They're kind of just mathematical functions, and they're stacked in layers. So you get a token in, and it kind of goes through a whole bunch of layers, and then tokens come out. And let's say there's 100 layers here. The first 15 transform whatever you say into a common pattern or meaning. And so what's really interesting, if you do a Chinese prompt versus an English prompt, by layer 10 or so, they end up being the same from the model's perspective. So it kind of transforms it first to a universal language or thinking, does its AI stuff, and then the last 10 layers before it spits it out to you is again depending on the language that you use, and transforms it back into either English or Chinese. So from an AI model's point of view, it kind of just doesn't matter which language you speak. By the time it kind of starts reasoning, working with it, statistical inferences with it, it is kind of normalized in a common pseudo language, which is kind of cool. And that's why it can do really cool things like, it has never seen a certain translation between two languages, but because it has a common layer, it can do ends up doing reasonable translation.
Also say the anthropomorphization it's an old issue. Like, I don't know about Mandarin Chinese, but Cantonese, the word for computer is din no, and means electronic brain. So connection to make it a human. But then the English word computer, that comes from the fact that there used to be a job called a computer that people used to do. So we like to make things human.
Especially about wearable AI. What do you think? Is AI or written our phone, or is we found to the glasses or your watch or somewhere else places? And his second question is more it is about interface overall, because right now we are stuck between screen, keyboard, and our voice control. But I think what must be right now is to compare that the new way of operation with AI. It's like data to data. What do you think about that?
I've got a fairly straightforward answer for you.
Please do.
I think whoever figures out the right user interface is going to make a lot of money. And I mean, the whole keyboard and mouse setup that we've been living with from the 70s is convenient user interface for what we had to do now. But clearly, it's not quite right for the future. I personally have a great deal of trouble talking to my watch to get it to do stuff. And I find that very cumbersome. So whatever that new interface is, whoever figures it out is going to revolutionize things. I don't know. Wearable AI, yeah, I mean, the tech's there already, right? I mean, you can embed chips in glasses, in watches, in rings, wherever you want to. That's not really an issue. The issue is then the technology that actually people will want to use, and not Apple's $6,000 pair of glasses that doesn't do anything.
Nothing to add.
It's a briefing, but throughout very last AI must, but for NATO, where the democracy would better than autocracy or better than communism. What answer even why?
But if you asked poor people the same question, you get a different answer. Like what?
No, but would it be just statistically regurgitating?
Yeah, the question is whether thinking about something or whether it's just.
Would it have nuance that no one else would ever put in a paper?
Excellent. So if we move away from policy, your question is, how is it reasoning? Is it using statistics or is it using thought, an opinion?
Yeah.
Yeah.
So the other example you gave before is that it now basically questions itself and recorrects. The sort of fun program.
No. So the training,
yes, a little bit.
the training of AI nowadays happens in 3 or 4 phases. So the first phase is the dumbest one, which is literally next word prediction. What you grab is you grab a bit of text, a paragraph, you cut it off at some random point in the paragraph, and you ask the AI what comes next. And so you do that, and if it gets it, you do that with lots of times, and when it gets it right, you say, okay, well, something in your brain is correct, and if it gets it wrong, you give it like a penalty. It's like it's called a loss function. You say like, okay, that wasn't quite right. You need to tweak the numbers of the brain a bit. So that's phase one. It's called pre-training. And GPT, generative pre-trained transformers. Pre-training is a big part of it. Used to take about 80% of all the compute. Second phase is a supervised fine-tuning, where we basically start teaching it what type of answers we want from it, and especially the shape of it. So in those, if you only do pre-training and you ask it, what is the capital of France? Guess what it answers?
If
No. It says, what is the capital of London, of UK? Why? Because in its data set, it's seen a lot of lists of questions, more often than question answer pairs. So it just thinks, okay, well, the next thing is another question. The next thing is another question. So it is totally useless to use for anything. So the second phase is supervised fine-tuning, SFT. And so in that phase, we do say like, what is the capital of UK? What's the capital of Netherlands? And then say the correct answer is answer. So this is a curated data sets, where the first phase is basically the whole internet, every book you've ever read, ever found, like all the text we can find, and now there's images. Just chuck it in, let it predict things, and that gives you sort of like the base brain. The second phase, and this is already starting to be important, because you can start shaping answers here. Google is has a slightly different philosophy than OpenAI. So they start giving different question answer pairs here. Does this make sense so far? Yeah. The third phase is reinforcement learning, and there's 2 or 3 types of this. And so here we are teaching it human preferences, 1, and reasoning, 2. And so one of the ways of doing reasoning, has anyone heard of DeepSeek? Yeah, DeepSeek came out, and they figured out a super simple way to teach a model how to reason. This was the formula. Here are 10 average difficulty math questions. Generate a bunch of reasonings. We're not teaching you how to do that. We're not describing that. Just generate a few based on all the things you've read before. And if you get it right, we give you a little bit like, do more of that type of reasoning. And if you get it wrong, we said, do less of that type of reasoning. And you just repeat this on mathematics. They did that with thousands of questions. And what they start seeing in the beginning, the reasoning is shit, doesn't work. It's not even faithful. The reasoning and the answer don't even line up. But after a whole bunch of iterations, it turns out that the reasoning starts to line up with the answer. Not fully, but more. And that the reasoning gets more steps and more sophisticated. And it starts to automatically, without anyone telling it, figure out that sometimes backtracking or double checking your answer is leading to better outcomes. And that gets rewarded. And this last step is causing a lot of the gaining reasoning. So in a way, do we program it in? Yes, because we say you got the right answer. No, you got the wrong answer. But we don't teach you which reasoning step or have to go back or do this many iterations. This is a bit technical, but well, the papers have very clear math on Google GRPO, group policy, GRPO or GPRO, DeepSeek, and the math is very, very understandable on how to do this, and this is just how it works, and you can replicate it yourself. Yeah.
Here and then here.
So get thankful at either way how and early let it hide out the upper question. So if you think about perspective and early, so what we think about our human actually very. So we had not function in AI. So the AI is vitamin gray. So we might have some those function upgrade.
So if we say that human can really and AI cannot, so basically AI say that AI just predict next pattern. Apparently we are not predict next pattern. So what a human? So I did not answer it. What do you think about what make our human can read? What actually the perfect adult? So ABK. So with just one material. So I study comparative neuroscience or my MS barriers. Oh, it's quite interesting. Well, I mean, one thing is sub-I. So we have to maintain our physiological state always. We have to keep our temperature, respiration, heartbeat. Well, that's common of now it's in most animals. But what's interesting, human has quite big brain. So it's like parade to the group side of the animal. So is animal living deeper, so more complicated, that's had social interaction, seems like they have more complex structure. So what the just a one curious for you. So my question is what's your ideas about what actually our human spirit for? So if they can we implement it into if we can implement into mathematical world, maybe we can implement it into an open chip and take some required penny. Maybe AI can.
So one of the things, I'll answer several of the things you said, but first thing that you said, let me ask you to complete the sentence. Mary had a little. Maybe wrong person.
Not in the training data. Not in the training data.
Everyone else. But humans are typically very good at
But that
predicting the
was
next
super
trip.
interesting because that was a cultural difference that everyone in Australia grew up with that and everyone.
So nursery rhyme, Mary had a little lamb, and you just immediately go to that word. So humans do next word token prediction as well. But I mean, that's not really the point of your question. The point of your question is more about what is the brain doing that is better, different, or superior, or not within the capability of a machine. And so this gets back to my original concern with digital AI, is that it is digital. It's a finite. You have a finite representation of state. Like everything's represented as zeros and ones, and a finite number of zeros and ones. So you can only ever be in one of a fixed number of states, a very large number of states, but a fixed number of states. But very large is important here because there's very large and there's very, 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 very large. And the number of possible configurations of these networks gets massively large very quickly. But the point is, the brain doesn't work like that. And you would know this. The brain has electrochemistry going on there. It's got possibly, if you believe Roger Penrose, quantum mechanical effects as well. It's got electrical stuff going on, but not digital electrical stuff going on. So the brain operates on a completely different set of states. And so when computer scientists take as a human brain and say, here's an artificial neural network, which is after all the basis of where AIs come from, there's a massive gross approximation in going from the human brain to multiple layers of neurons in an artificial neural network. And that's why I keep pushing back against reasoning in the digital machines. I don't think they have the capacity for it. And I think whilst I could be wrong, but I think the emergence of this reasoning requires more than what you can have in a digital machine. I was going to say something else, but I've forgotten, so I'll let you answer instead.
What I find beautiful is that I'm gonna abuse a bit the argument you use, is that it feels a bit backwards. I feel there's something special about humans, and defending it from that perspective. And I think it's really human. And I have the same feeling. Like, I want to believe that there is something special to my brain and to my soul that no machine can ever replicate. And I feel that must be deeply true.
Well, no, I'd be quite happy if a machine could replicate it. Then I could be downloaded to a machine and I could live for the next 1,000 years.
And so I think who shares that probably sentiment? Probably everyone here. Like there must be something uniquely special about us. And I want to believe that to be deeply true. Where I struggle personally is that if I see a technology getting more general, more capable, and the pattern is, and I'm repeating myself, is like, oh, a machine can never do that thing. Oh shit, it did it. Then this will be 10 years away. Oh no, it did it. This will never happen. Oh shit, it did it. And that is in breadth and in depth. Then I start asking the question, and I think that's a humble position. It's like, ooh, I thought we were special in 20 ways. The first 6 have been eliminated in rapid succession. Where does this train stop? And I'm not saying, I know for certain it doesn't. But I'm just saying, look, I think we should keep an open mind that 7, 8, 9, and 11 will be coming next year. And maybe that keeps going. I'm not sure. I don't argue. I'm 100% sure these things reason, and I'm sure of it. And they will keep being better at reasoning. What I'm saying is that, with these trends I'm seeing, I think it's wise to keep an open mind that they will be getting more capable, and we shouldn't be too surprised if after the first 6 things we're surprised about, another 6 things come. Because if you're 6 times surprised, then the 7th time you should be like, maybe I should just change my priors. And so I don't know if there's some special sauce we will always have, or that there's a special sauce that we'll figure out in a year and put in AI. I don't know. I'm just saying I think it's hard to defend given the trend. I'm sure this will never be blah, 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 blah.
I'm not taking the position that we have a soul that is of some sort of unique characteristic. I'm not saying we don't. I'm not making that argument. I'm not saying that is the special sauce that we have. I'm just saying that to model the way that humans reason, I think currently the computer's got the wrong architecture. The other point I was going to make that I remembered now, which is also to the same point, is the human brain uses a lot of energy, about 20 watts of energy. How much does it cost to train ChatGPT?
Yeah. So I hear this argument a lot. And so to write a full paragraph, a human, only 20 watts in the brain, but to do that, we have to sleep, go to the grocery store, produce a whole bunch of shit. And so that gets conveniently removed from
So that's 24 kilowatt hours then.
And so to produce the same paragraph, and if it's like let's say a summary, which AI is reasonably good at, it is already more watt efficient for an AI to produce that paragraph if you take into account the food, driving, computer, and all the other shit that a human needs, and sleep, and have sex, and raise kids, and do all the things, right? You can't just take that half an hour that it writes the things.
I'm pretty sure I could write a paragraph without the sex.
But how good would it be?
Yeah.
So, I'm not supposed to ask questions as an NC, but I am super curious in what I'm seeing here. And I think it is kind of something you keep hearing, where there's this kind of dichotomy of like humans have this work as a value based on what they can produce or what they can think, what they can reason, or what they can write, or anything. And then now AI has come along as kind of the cooler, smarter, hotter kid in school, and everyone's freaking out and it's like, okay, well, what's my role now? But I'm really curious about why that's the argument, and why is it not like amazing? Go do all my homework. I'm going to be on the beach. And why are we not just being like, excellent, someone's figured out how to make this guy write emails. I'm all like, just redefine your life.
Because we don't want to be redundant.
But redundancy when we're on the beach is amazing. Why are we not like embracing our own redundancy and just living a like layer-filled life?
As long as you can afford the margaritas while you're on the beach.
I
If
think
you're sleeping on the beach because you've got nowhere else to go, that's different.
We just need to redefine. Sorry, you go and then we'll go.
it's hitting, I think, probably the most, one of the preeminent mathematicians of our state. What just happened last week is quite substantial. So it's the quality of that paper that got released is my understanding is to the quality that it can make a mathematician. If a human would have done that, Michael had described a paper early on that was written by an AI that had a reasonably novel mathematical insight and disproved something. The quality of that is my understanding. If a PhD student would have done that, it would probably secured him a pretty decent academic career. It was of the quality that is a career-making find. Is that?
It's certainly a significant way towards a PhD. So to give some context, the AI labs have been working on applying their models to solve a set of problems known as the Erdos problems. So Erdos is a famous mathematician who published many more papers than me, has many more citations than me. He's now dead. And so, however, mathematicians have this thing called the Erdos number, which is how well connected you are to Erdos. So if you published a paper with Erdos, your Erdos number is 1. If you publish a paper with someone who published a paper with Erdos, it's 2. Mine's 3, which apparently is not too bad. It's actually the average for Fields Medals, which is I'll take that. I'll take that. But the point being, Erdos was no slouch. He was a pretty good mathematician, and he was very collaborative. A lot of interesting things about him, but he had this list of about 1,000 odd problems that were unsolved conjectures, largely in number theory. So number theory is interesting because they are problems that can usually be described fairly succinctly and proved axiomatically. So you can have deduction steps to get to the proof with a fairly tightly closed system. But of these 1,000 problems, many of them are unsolved. There's a website you can go to and just list them all, and it has the current status of them. And the AI labs started attacking these and solving some of them. This happened like last year. And it turned out that they solved many of them. It turned out that some of the solutions were problems that were actually solved, but people didn't realize that it was an Erdos problem they solved, so it wasn't on the list. Some of them were actually quite trivial. 1,000 problems may surprise everyone in this room, but there's not that many people in number theory in the world. So some of these problems hadn't really been looked at. So solving them maybe wasn't such a big deal after all. But what happened last week was the problem that was solved last week was actually a significant problem in the sense that serious mathematicians had looked at it. It was stated in the 1960s. Essentially, the problem says, if I have a set of n points, how many of them are distance? How many pairs of them are distance 1 apart? So put in a bunch of points, measure the distance between them. How many of them are some fixed distance? So one way to think of this is if you have a grid of points, right? Then everything is the same distance 1 apart. And mathematicians thought that the grid was the best way to do it. And if you have a grid of points, then the number of pairs of points that are distance 1 apart scales with the number of points. Right? What the AI did was show that actually there's another construction where it scales like not n, which is what a grid would give you, but n to the power of 1 plus something bigger than 0. The AI's proof had that something at about 10 to the minus 35. So very, very slightly above 1, above 0. So the scaling was proved. And it said, right, there's my proof. You've asked me to prove this conjecture, I've proved it. And one of the reasons that I'm still holding out for humans is that 2 days after this, one of the human mathematicians that was looking at the proof said, actually, I can turn that 10 to the minus 35 into 0.035, I think. So that's chopping off 33 zeros from your number, right? Making it 33 orders of magnitude bigger. So that's, what's that, a billion million.
So the AI had the creative insight, and then the human improved on it. Is that what you're saying?
So what I'm saying is the AI did have the key creative insight, but the AI didn't go and create the beautiful proof. The AI just did what it was told to do and stopped there.
Well, why I was raising this is and connecting that to that sense of value if I were a mathematician, and I wouldn't be as good as Michael, but I would be like a run-of-the-mill mathematician. And I see this AI improve and now starts to do proof that I could have never done in my career. I would have a pretty big existential crisis. That would be like, and I would be in number theory. I would be like, oh shit, this might affect my career, and it's a hard pivot. And so computer scientists have had this feeling now. Some mathematicians, not of your caliber, but on a different caliber, are starting to feel that, and just be like, AI will somehow solve it, and I can sit on the beach. So for them, it means like, okay, my position might be irrelevant. I might not have a salary. I might not be able to maintain my family, and so
Yeah, I'm glad I'm glad I didn't go into number theory. No, I think so. My apologies. I gave a public lecture 2 years ago, I think, where I talked about AI proving mathematical theorems, and outlined some of these same ideas. And I was skeptical back then as well, but showed what it could do. And some of my mathematical colleagues came up to me afterwards and basically said, holy shit, I'm going to need a new job. There is a real threat to some part of mathematical reasoning being posed by these machines, by these algorithms. At the same time, and to Euren's point that I'm setting benchmarks that keep getting surpassed, but the proofs that the AIs are coming up with still need a human to translate them into something meaningful. There is a separate question, of course, that if AI can do all the stuff that these mathematicians can do, then not only what is the point of the mathematicians, but what is the point of mathematics? Mathematics, partly pure mathematics particularly, exists because it's a beautiful thing to do that reasoning. If we can't do the reasoning as well as machines, and we can't understand it as well as machines, maybe we're not qualified to enjoy the beauty of it.
Then I don't think that you need to be qualified to enjoy beauty. It's the same thing about the chess. Like, you can have a machine that plays chess better than any human on Earth. The human is not necessarily playing chess to be the best human on Earth to play the chess. They're playing chess because they enjoy the game of chess. He was like, or this is not so much a portion. I mean, a competition.
Just turn a comment into a question by saying, what do you think?
We could probably use it as little, which is always, to think the business scenarios that all, like let AI do the job of our own children. We need purpose, right? We actually have to have purpose in order to come in book it. And despite the popular from the book that we get part on the airport, that it happened when we were out a week and, or don't work at all. We have a Bible book that would type essentially without purpose, we integrate it and more passing there, literally. So I think the trigger for AI, for replacing all that, is not so much the financial implications of that, but there's also implication for what the meaning, but what's the purpose of my movement, which I then professor people really do boy. As a mathematician, if machine can be making happy, there doesn't mean or much comprehension so I think more of a comment that from psychology point of view, right? We have to have purpose, and we've seen this specifically in retirement research. We know that people who not have purpose once they retire, work is tied to purpose for majority of the population, the way that our society is structured. So for majority of retirees who don't have a new purpose once they retire, they actually die within 2 to 5 years. And that is well documented. So, evolutionary, you don't have a purpose, you'd literally shut down and you die, right? And so I feel like there's a pension and that we experience in society at the moment to say, well, it's not about the beach and my burritos. It's about that if you don't have a purpose, you're not likely to last digitally, emotionally, right? So I say that there's that triggering existential threat, is my sense of what's happening underneath. And then the other thing I was going to say, if I may, sorry, but maybe 2 comments. is going back to the earlier discussion about the states of that define book correctly. So Yolosn is a hub with this or Kimali. Is but then like we know that we are also very limited in our states. We don't hear certain it ranges at certain animals here. We don't see at certain other ranges perceptually. We're quite limited actually compared to many other animals, right? So what's to say that machines are limited by zeros and ones. We are limited by even our brain chemistry that goes back to this thing. Well, where's the supremacy thing coming from, right? So why would it even limit the antitheria with this other way of knowing, other way of solving, other way of being, other way of perceiving the world?
No, I think that the dolphins have got us all over. And so long, and thanks for all the fish. And I think I'm not saying that we're somehow completely over the supreme in any sense there. I'm just the argument is that there's some things that you can't expect a machine to do that you can expect a human to do because of that difference in capacity. So that's the only argument there. But to your main point, I think a sense of purpose is vitally important. And I have a counterexample. Sorry to talk about mathematicians again. Another colleague of mine who's close to, if not well past retirement age, and still lecturing first-year students. I don't think that's his purpose. I don't think he finds it to be, but he's still an active research mathematician and recently discovered ChatGPT, and he thinks it's fantastic. It's like I've got this PhD student in a box on my desk, and they never sleep, and I can get them to do stuff straight away. And there's opportunity. I think representing it in just terms of it's a change of what we can do and a change of what it's an enabler rather than just a disruptor. So I think there's opportunities as well as like threats for. Yes, there are areas of mathematics particularly, but computer science, other subjects as well that will become less necessary. But there'll be new avenues that open up as well.
I've followed most of it. I had a beautiful set about meaning. I fully agree. Meaning is core to us humans, and the fears of having less meaning or the changing is obviously almost existential. So that makes total sense. On the different kind of types of thinking or reasoning, and I think in a lot of places it will be complementary. And before this, we had a little chat about my self-driving car. And I was like, well, why do I believe it's more safe? Because the stats say it's safe, but why does it resonate with because it thinks different than me. And so it's good at some things that I'm bad at. What am I super
Staying
bad
at the road, staying to the speed limit, obeying the stop signs.
Exactly. Yeah. And so what humans, but anyone, is like, who here can put hand on heart? I've driven for 2 hours and not 1 second drifted elsewhere with my thinking. Who can claim that? No one here, I'm sure. Bad day, tired, phone rings, something, radio not working. So something a self-driving car is excellent at, it will not get distracted. It has only one task. And so in a way that's different, but complementary intelligences. So maybe it is not as good as knowing what to do when 5 weird dogs and things happen all at once, but it is better at paying attention. And so I think in a lot of situations, it's like the self-driving car situation, where our artificial intelligences complement the human intelligence, and we can do just more good things together. And so I think it will just unleash this whole swat of cool new things we can do or the same things we can do better, cheaper, faster than we were doing before.
Okay, one question here, and then we're going to do final thing. We've been talking for over an hour now, so we're very fast.
So this conversation make it be the midst and that we have many different parts with the same video or light of the each one a day. So
did they correct to say that AI adonai valid I their dead book and I book either in party ends because it was that you cut career need an idea that a determination where AI or it shall be a movement but in the habit preparation but you penable but it's not would you know you uh it's like that they are capable that method content or when you talk or up the broad I let that maybe a my stupid delete.
You want to go?
Yeah. Bit layered. The can you ask the first question again?
If it is he compare the AI and all that he and
I would say associative is or kind of predictive intelligence would be how I would phrase it. But there seems, in my understanding, some emergence of light forms of other types of reasoning, or at least copying some of other types of reasoning that humans do and emulate or simulate them quite well. So yes, they have a particular type that they're good at. I wouldn't call it per se analytical reasoning, but something in that light, yeah.
the setting by at the moment and in the OPF people that and a carried by it in a bad shape.
You guys heard of the philosophical zombie? Anyone here who has heard of that? Do you? You're the lecturer here. Would you like to explain it or?
No, you go ahead.
So, let's say you have a clone of a human, a zombie, like a Lisa zombie next to Lisa, and we assume, as in the thought experiment, that Lisa is sentient and conscious. Philosophical zombie, because you, the philosophical zombie is not. However, the philosophical zombie produces exactly the identical outputs that Lisa produces. You cannot differentiate from the outside what type of answers he produces. Is there a difference between Lisa and a philosophical zombie? And so why that matters is like if an AI simulates emotional intelligence in a different mechanism than a human, but gives identical results, doesn't matter. And I don't know, say there's an answer, but it's a cool philosophical frame that gets used in a thought experiment.
It's the thing, Michael, the core of your argument is that it does matter.
Yes. Yeah. I mean, I think essentially, yes, but also the argument is that actually these two things are not identical. They appear to be very similar. But if I put a plate of raw brains in front of you and the zombie you, then I'm assuming the behavior might start to be quite different. So my argument is that there's a simulation of human-like behavior, but it's not just that it's a perfect simulation. The evidence that we have, and maybe it's getting smaller and smaller and it's going to zero, but there's still differences between the way AI behaves
Fully agree.
and the way humans behave in certain cases. I mean, it can write a novel, but typically it's a pretty bad novel.
For sure.
So it's still not there yet. But,
Yeah, I think it's not growing.
and so I mean, and again, to me, the yet comes down to the architecture. And I would think this to your first part of your question. Yeah, I think the reason for this is that these sorts of analytical reasoning, and I'm more happy to call it analytical reasoning, but I get the meaning of associative reasoning as well. These things are very easy to codify for computer software to do. emotional support is much more difficult to codify and to quantify. I mean, the very early chatbots that psychologists use, like Eliza from the 70s, set up to psychoanalyze people, just basically said, oh, why do you feel like that? Or how do you feel today? And just, it's very easy to do that at a very poor level. It's perhaps much more difficult to do that as well as a trained human would, and with the same emotional intelligence.
Yeah,
We're gonna be
philosophical zombie. I think it does in a sense not matter. If I get a letter from my GP explaining some medical results, and he has to do it in 2 minutes and smash it out, and it's human intelligence and all the bits and bobs, but he rushes and it's terrible. Versus an AI does the same report, and it is statistical pattern matching, but better quality, nicer, more empathetic, more clear explained, then I don't think it matters. I think most people would prefer the AI version, and that's what we see happening more and more. Yeah.
But most people still want to go and see a human GP.
For now.
Alright, as a final question for my very one is, what would you like everyone here as they continue on their lives to do all of it? Would you like an action, bro?
I'm going to give a flippant one and have time to think about a more serious response on your own response. My flippant response is just have a thought for the unemployed mathematician on the beach with somebody.
Two thoughts. One is, and I'm repeating myself a little bit. If we've seen, hey, an AI will never be able to do X, and then that turned out not to be true, and that happens over and over and over again, I recommend keeping an open mind, that will keep happening a few more times. We don't know where that stops. We don't know which other modalities or types of reasoning or thinking will be absorbed in this, but I would keep an open mind that it might keep going and that might affect us. And so we shouldn't kill the dialogue. AI will never do that, and therefore we don't have to worry about it. I think the better stance is like, we don't know if AI will be doing that, so we should at least spend a little bit of our time thinking about what consequences that might have. It's one.
I would say just enjoy being surprised and try it for yourself. Don't just believe everything that you read on LinkedIn or as a post on X by one of these tech companies about how something is doing something. These technologies are very accessible. I mean, you don't have to sit back and say, oh, gee, I heard that it does this. I heard that it does that. You can go and do it yourself.
I said I have two things, and Michael, allow yourself to be a little bit amazed. Like, I'm having a 7-week-old little boy, and half the time I have no clue what to do at 3 a.m. when it's crying, and I've got this wonderful magical genie in a box. I'm like, I do not know what to do, and it's been extremely helpful in so many ways. And I am serious. And
Nappies on the head.
and a lot of parents are like this. And the fact is that we went from 0 to about 70% of the Western population using ChatGPT regularly. And yes, there's a bit of marketing going on, but most of that was worth of mouth. Only recently marketing it started. That was just because it is useful to us. And so, we have this really cool technology available to us, and it's helping a lot of people. And we are kind of bashing it and taking it for granted. I do think a little bit of wonder, like, hey, cool, we have this magic kind of technology that is helping us in various ways, and I think that's really fascinating. And it's as far as I can judge, it's helping a lot of people, and we shouldn't forget that part. Yeah.
I was just going to echo the last words and say that I think, despite certain American politicians trying to destroy the world, we're lucky to be alive now. It's an amazing time to be alive, and probably the best time in human history so far.
I agree. Thank you so much, Michael.
Please join me in a round of applause, Richard.
No problem.